Okay, so we will start now test of our 20S9P battery that we produce as a smaller, lighter battery. We will show the power output of the battery connected to the ANT BMS, and the discharge stand will be this spiral that will get hot and at the same time will discharge the battery. We have here amp meter, we have here voltmeter showing total voltage of the battery, as well as BMS connected to the phone. It will show the voltage of each cell's total amperage, power, and all other parameters, as well as the temperature. Plus we have laser thermometer that can show the temperature. Right now it's 15, and we can see how the temperature will show during the test on the complete battery. Let's start it now. We switched on, and immediately you can see the readings 170 amps. This is way more than the battery will be drawn in the normal use. You can see here all the parameters, the voltage of each individual cell, and let's measure the temperature. Now it's 16, 17, 18. The ambient temperature here is about 15 degrees here, plus minus. You can see maybe on the wires a little bit more, but not much. To show you that this is really getting hot, you see the temperature rising 400, 440, 450 and rising. Meanwhile, the temperature of the battery is not really getting too much hot. Show 20. You can see the parameters here. I can feel a little bit of heat from the battery, not too much. Maybe from the wire, and also the battery is getting hot because there is a radiation of the spiral. It's too hot, it cannot read it anymore. And as you can see, the amperage is still 150 amps, the voltage is 66 amp, and the BMS shows that the process of discharging is happening. It's now around 10 kilowatt discharge power, which is the peak performance for our bikes. So you can clearly see the battery is not getting too hot. And on the other hand, you can see the discharge slot is getting too hot. I will need to stop the test before we burn our spiral. Stop it, please. So you can see it's glowing red hot. I can feel the temperature, the heat standing 1 meter away from it. And yeah, the battery is voltage back to 74, 75. You can see here the voltage difference between higher and lower cell is 0.0045. So it's less than 1/100th of the voltage, the difference between the cells. We're using Sony VTC6 cells for this battery. They are high discharge cells, so that's absolutely fine for this cells to be drawn on this high power output. And we can measure the temperature here. It's 30 degree. You can see here 31, 32, 33, 31 again. The BMS temperature 32. when I shine on the metal, it's show a wrong reading because it's metal, and on a shiny surface it doesn't work very good. Here the temperature is higher because the stand is right next to the battery, so it shows a very high temperature. But if we measure it here, for example, 34, 30, you can see 29, 33, 31, and again if I touch it, I can feel it's warm but not hot, exactly like 30 degrees realistic value. So the voltage is going up. It's now at 77 volts, and the difference is 0.002 volts between the cells, so it's perfectly balanced. You can see the readings from the BMS temperature probe that it's 33 degree, exactly what our thermometer showed, so it's also the correct readouts. And yeah, this test was made for you to prove that the small battery, although it's smaller in capacity, but at the same time it's smaller in physical size, in volume, in weight, which is important for some of you guys. Of course, the battery will be put it later into the metal box, just for the purpose, for the show purpose. We didn't put it inside the box, but wanted to show you exactly like it is when we make it. So I think that's it. We will now make the test of our standard battery.